Welcome to the graveyard of Tesla large drive units. Now I thought I'd make this video for those that are new to EV conversions to give you some idea about what it takes to spin a Tesla large drive unit for testing purposes. So let me walk you through that now. First of all, there's a few misconceptions about how much power you need. What I can confirm is you just need two 12-volt car batteries in series giving you 24 or 25 volts, and that is enough to spin the drive unit. You'll also need another 12-volt battery. Now that is for your low voltage side. You will need an open inverter logic board. Now these can be bought on the Open Inverter forum in their shop. This is a drop-in replacement board for the OEM Tesla logic board, which you effectively will do away with. So this one comes out, this one goes in. In terms of other components, you need a couple of contactors and a pre-charge contact and some pre-charge resistors. You can buy those from zeroev.co.uk. You'll need a throttle pedal and a small 12-volt switch. You can buy those off eBay. That throttle pedal is, or that potentiometer is from a Porsche 911, 996 Porsche 911, but you could use it out of a BMW E46, which is what I think Damien Maguire recommends. Other components that are required is a harness. Now this harness here is from a company in the US called DIY Auto Tune, and it's an MS3 Pro center harness. You can get these imported to the UK for about £100. It's absolutely worth it. I wouldn't recommend buying that connector on its own and trying to pin it up yourself. It's just not worth the hassle. Now that connector is used to power low voltage to things like your contactors, your throttle pedal, your switch for direction, low voltage power to the inverter itself, and also to the encoder, which is mounted on the other side of the drive unit. Now on the what we'll call high voltage side, let me just walk you through how that's working. So I've got my connections from my batteries coming here. So this is 25 volts onto these contactors. So effectively what we've got going on here, when I turn on my ignition, my negative contactor is going to close, as is my pre-charge contactor, and I'm going to send my high voltage at 25 volts round the main contactor and to the drive unit, and then I will get that 25 volts on these bus bars. And let me just connect my multimeter onto those bus bars and we can just go through that process. So we can see there, we're not even registering a volt. So let's start our ignition. I've got a simple switch here to simulate the ignition key to position 1 in a car. So what happened there when I clicked on? Negative contactor closed, pre-charge contactor closed. I now have power going to the inverter. And I can see that because I've now got 24 volts on those bus bars on the inverter. I'm now going to turn my key to start the ignition, and to simulate that, I've just got this wire here, which I think is pin 23 of the harness. I'm going to give it 12 volts. And what you heard click there was this main contactor. Now that contactor is now closed and the pre-charge one is now open, meaning that my high voltage power is flowing through these jumpers, through the contactors onto these large cables, onto the bus bars. And you can see I've got just under 25 volts there on those bus bars. I'm now ready to spin the motor. Now I should say, before you would do that, there are a few settings that you need to change on the Open Inverter logic board. And there is a Wi-Fi connection to this board once it's powered up, and you can log in and adjust certain settings which are fundamental to doing testing purposes. Now I'm going to put a quick video of me doing just that within this video, but effectively there are 3 or 4 things that needed to be changed for testing purposes in order to do that. So let's actually spin this drive unit now. So I've set my direction, so I know that I'm facing forward. That's already done. I know that my ignition's on. The drive unit is all powered up. So let's give it some throttle. Okay. Forgot to actually select a direction. And it's that simple. Perfect for testing purposes. What you don't really want to be doing when you're testing one of these, particularly as a beginner, is giving it 400 volts. So doing it with just 24, 25 volts makes total sense, because if you do make a mistake or short something out, it isn't going to be the end of the world. You're unlikely to damage your inverter if that happens. So it makes sense to set up a test setup like this for just spinning that motor up for the first time. And once you're comfortable with everything, you can then install it into the car and give it the full voltage. So there we are. Hope this was helpful. Again, the video is aimed at beginners and gives you some idea into what it takes to spin the large drive unit. What I would say from a wiring connection point of view and wiring diagrams, I'm not going to go through that today. You can see that on page 1 of the Tesla large drive unit support thread on the Open Inverter forum. That gives you the detail about the wiring connection, so refer to that to know what goes where. But there we are. Hope you enjoyed, and thanks very much.